Do the thing. Shouldn't be terribly long. Who's still going? Okay. AB times BA, how do I even know if they're possible? Because it does say if possible.
If the ones on the inside.
Check their dimensions. 3 by 2 times 2 by 3. The insides match tells me they're good to go. The outsides tells me the dimensions of the result. So, if you need to grid it, grid it. And each position in your answer matrix is going to result from its row by column. So if this is row 1, column 1, I will take row 1 by column 1. And here we go. 28 plus 10. We're now in row 1, column 2. So row 1 with column 2, 0 plus 30. We're now in row 1, column 3. So take 4 plus 40. We're now in row 2, column 1. So take row 2 times column 1. 7 plus 18. We're now in row 2, column 2. I'll take 0 plus 54. Row 2, column 3. 1 plus 72. We're now in row 3, column 1. Negative 42 minus 6. 0 minus 18. And negative 6 minus 24. I'll just write it up here. End result, 38, 30, 44. What's that? 25, 54, 73, negative 48, negative 18, negative 30. How'd we do with round 1? Okay. Round 2. Hey. I check the dimensions. We have a 2 by 3 times 3 by 2. Interior dimensions match, so it's good to go. Outside dimensions tell me my end result. So I'm going to have a big old honking 2 by 2. If you need to grid it out, grid it out. Actually, I'll just use this. So we do it again. Row 1 with column 1 for element 1, 1. 28, 0, and -6. Row 1, column 2. 35, 0, and -3. Row 2, column 1. 8 plus 6 minus 48. And finally, row 2, column 2. 10, 54, and -24. All right there. If you're going to die in my class, do it in the hall so I don't have paperwork. Combine stuff. Get 22, 32. What's that? -40, -34. And 30, 10, 40. Yay? So there's a grand total of 13 terms up here. And what usually happens is someone that screws up will screw up a row or a column. So I'm kind of forced to do a semi-Likert scale here. What we're going to say is, if you got all 13 terms, 0 wrong, 5. Assuming you have the work to back it up. If you got 2 terms wrong, a 4. If you got 4 terms wrong, a 3. If you got 6 terms out of 13 wrong, that's a 2. If you've got 8 terms wrong out of 13, you deserve the 1. And I'm going to say if you actually went 3 out of 10, well, then you need to come have a chat. Okay? Yeah. Good?
Yep.
Okay. All right. Bonk. No. The homework, basically it's can you do it or can't you? Just like before, especially the 2 matrix practice problems, there's no point in me going through the whole thing up here because of how many steps there are and how many little pieces there are to it. Instead, I'm going to say, y'all got to ask questions. Okay? The most common questions were, and this is for the last couple of days, is a kid gets there and none of these columns are nice. They say, what do I do? Force it.
Fraction.
Well, if you want to go to fractions, you can. Most kids would rather use big numbers than fraction numbers. But say this is like 39 and -17. Force it. 39 row 3 plus 17 row 2. And use the calculator. If you haven't screwed anything up, it should come out clean. Okay? Just force the issue. Use the calculator to make sure you don't screw up any arithmetic because now you're dealing with larger numbers. And it'll work. Then you'll have a 0 here. Or sorry, a 1. You'll have your 39 there, a 0 here. You'll divide and have a 1 there. Well, now you're good to knock out these two. Now you're good to divide here and knock out this one. Okay? You just have to force yourself through that step. That's really the question that I've gotten the most. The numbers aren't nice, what do I do? Mom, he's being mean to me. Hit him! Force your way through it. Okay? Don't do that. That's mean. Well, sometimes they deserve it. So, we're going to head into 6-4 instead. I said in PreCalc, we got this, I call it the dubious honor of we're supposed to prepare you for stats, trig, and calc. Spearfish has trig as a separate class. Normally it's rolled into this class. But normally this class doesn't have to review so much Algebra 2. So chapters 1, 2, and 3 were solidifying Algebra 2. Chapter 4, preparing you for trig. Chapters 7 is for both trig and calc. 6 is more for the calc aspect of it. And what we're going to do today, this is kind of heading towards the back end of calculus, even Calc 2. That's why we're going to get rid of one of our examples, because it's not 100% necessary until Calc 2, so that's what we're going to cut. In order to do derivatives and integrals later on in calculus, sometimes you're going to have to break functions down. And you have to see the mechanics of it now before you get to the why would I use this. That's why it's called pre-calculus. We just show you the bare skills and then you'll go apply it. Y'all remember side quest? No calculator. What do you do?
Multiply the right one by 5 and left one by 7.
Right? Okay. So that's like 3rd grade. And then you get up to Algebra 1. We introduce you to rationals. Now what?
Multiply the right one by, again, an exponent.
You really don't freshman this.
I wouldn't even think to do that.
I've seen it in PreCalc.
What do you do? Did they just add a 5 to the
Because now it would be x plus 2. That breaks math in a half. Don't do that. Okay? You get the meme, right? No, it doesn't work that way. Instead, because this is a summative expression, it has addends. I'm adding things together. I need factors, so you have the entirety of x minus 3 and the entirety of x minus 3. The entirety of x plus 2 and the entirety of x plus 2. You disturb it. Whoa. And you'd get 4x and 5x is 9x. You'd get negative 12 and 10 is minus 2 over the quantity x squared minus x minus 6. Do it in reverse. That's what partial fractions are about. Where instead of, I want you to combine them, I want you to break them apart. Okay? And to break them apart, first I have to understand what are my two parts going to be comprised of. So I'm always going to start by factoring my denominator. And that tells me that I had something over x minus 5, and I added it to something over x plus 4. Now there's entire proofs for this stuff. Again, Calc 1 and 2. For now, we're just showing you the mechanics. Where if this is a linear factor, 1 degree less than that is a constant. I'm just going to put a constant above them. Right? That's what I just had on my little side quest. I had 4 over thing plus 5 over thing, or 3 or whatever it was. So I know that this is how I got there. So now, find out what the numbers are. By u need a x plus 4, u need a x plus 4. U need a x minus 5, u need a x minus 5. You're reconstructing the process with an unknown variable in there. See how the entire denominator is now x squared minus x minus 20, x squared minus x minus 20, x squared minus x minus 20. What happens when I multiply all of it by x squared minus x minus 20? Bye-bye. So, womp womp. So it doesn't just disappear. If you multiply by that, it will cancel. Okay? So now I have x plus 13 is disturbed ax plus 4a, disturbed bx minus 5b, and what do you think now? We've run across a couple of problems similar to this. All the way back to section 02, we ran into something similar to this. Okay. X stuff has to be X stuff. Constant stuff has to be constant stuff. Right? We first saw this with, it was like 6j minus 5ki equals 18 plus 20i. It was the first time we saw this. And they said, solve for j and k. You're like, but how? Put your real friends with your real friends. Put your imaginary friends with your imaginary friends. Right? The imaginary part won't have anything to do with the real part. So I would say 6j is 18. I would say negative 5ki is 20i. Can't you just divide to find j and k? So that concept is coming back to us here, where now I know I've got this much x and this much x will make this much x. So a plus b has to total up to 1. I've got this much constant, and it has to add up to this much constant. So I know 4a minus 5b has to equal 13. You just made yourself a neat little two-variable system. Solve it like you're back in algebra half. I'll do top row by 5. 5a plus 5b is 5. 4a minus 5b is 13. Womp. And get 9a is 18. A is 2. Plug it all the way back in. 2 plus b is 1. B is negative 1. So, finish it off. The whole point of this was I knew it broke down into something over x minus 5 and something over x plus 4. I just had to find out what they were. I just found out what they were. So make sure you actually write it. 2 over x minus 5 Now you can either say minus 1 over x plus 4, or you can say plus a negative 1 over x plus 4. Same thing. Now someone asks, what if I put my x plus 4 first? No, you won't. Your x plus 4 will match with a. Your x minus 5 will match with b. But that also means when you get your common denominators, you're multiplying a and b by a different set. At the end of this, my a will be your b. Your b will be my a. But they're still going to match with those denominators. Because not only did you swap the variables, but you also swap the denominators with them. Okay? It's like if I have a over b equals c over d, well, what if I swapped those and swapped those? Oh God, no. It's all wrong now. No. If you swap both, the numerator and the denominator, then they're still paired with each other. It's just they're going to be in a different order. Okay? So start with baby steps. Start with just 1a. Factor your denominator, write out a over thing plus b over thing. Head down the rabbit hole. Okay, all right, at least starting the setup right. Okay. Get your common denominators. Distribute, combine like terms. Now you get to match stuff and make a system. We have 2 is a plus b. We have 5 matches with a minus 2b. Solve your system. Maybe I'll take top row by just -1, -2, negative a equals negative a minus b. 5 a minus 2b, womp. Getting negative 3b is 3, b is -1. Plug it back in. If b is -1, add 1 to the other side. A is tree. And you have to put it together at the end. You can't just quit. Step 6 is to actually write it. Write the decomposition. If I said that A is this and B is that, then I need to say 3 over x minus 2 minus 1 over x plus 1. That's my answer. And again, how do I check? How do I know if I'm right?
Solve that.
What do you mean solve?
Solve it to get to that.
Close. I will combine those two. Solve means I have an equal sign and I actually found a value. But if I take this times x plus 1, take this times x minus 2, that numerator should come out as 2x plus 5. Okay? Can you do it when the factoring's got a little more mojo to it? For some reason, you show kids all the way in PreCalc something that requires either box or AC method, and they flip out. So whether you got the mental mojo to just break it up, whether you have to go box, AC, heck, I don't care if you do quadratic formula on it and then reverse engineer the factors.
No.
I hope we didn't forget Algebra 1. You know, if you got to take the side quest, If you have to take the side quest to factor that, then take the side quest. At this point, you're in the stage where, y'all, this is from like the last 4 classes. You do that however you're going to do that. Okay, last hour I had a couple of kids who were big fans of box method for it. All right, go for it. Common denominators. Okay, starting to get towards little tips and tricks. Those numerators are going to start getting longer. This is only example 1. When you distribute, it might not be a bad idea to start lining them up by like terms, right? Instead of just one big long chain. Instead of saying ax minus 3a plus 2bx plus 2b in one big blah, 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 start lining them up by like terms when you simplify each numerator, because it's going to help us as we get towards the system to see where my like terms are. A plus 2b is 1, and negative 3a plus 2b is 11. I'm going to cheat and just negate one of them. Getting negative 4a is, oh wait, I missed something. Okay, that's just 1b. Back that math up. I was close. That's x plus 11 is ax minus 3a, 2bx plus b. There we go. So we'll have 1 is a plus 2b, and 11 is negative 3a plus 1b. There we go. Solve your 2-variable system. Bottom row by negative 2, top row by 3. Don't curve. 3 plus 3 is 3a plus 6b over 11 is negative 3a plus b. Womp. 14 is 7b. B is 2. If b is 2, plug it back in. 2 by 2 is 4. Subtract. A is negative 3. Write the decomposition. Don't just quit. If A is a thing and B is a thing, write them. Negative 3 over 2x plus 1 plus 2 over x minus 3. Did anyone write their initial factoring, the purple step? Swapped? Started with x minus 3? Still ended up with, you ended up with A is 2, right? So it's going to work out. It doesn't matter which way you write it. So, feel okay about it? Those steps are all right? If you've got those steps, you're okay. Now, the whole point of breaking this down is to get its individual components as small and irreducible as I can. Notice that the 3 examples we did, the numerator was always less than the denominator. So what happens when it's not? Okay. If y'all are good, we'll just go straight to this. Now, ruh-roh, Raggy. The numerator is the same or greater degree. When that happens, what does this bar mean?
Parentheses.
Parenthesis this divided by parenthesis that. Let's hop in the time machine and go all the way back to 3rd grade. What's out as a mixed number?
7 and a 4.
No.
No,
6 and a 4.
How'd you do that?
Well, because 6 times 4 is 24. Just add 1.
And if you're talking about the multiplication aspect of it, the division aspect of it is just as likely. The way that we first learned this, all the way back in elementary school, so we said 25 divided by 4 is 6. 6 times 4 is 24. We subtracted and got 1 left over. It's 1 out of 4, which we had to do with our long division of polynomials. Step 0. Divide if you have a numerator that is equal or greater degree. So, because he's back again. We're going to get a little side quest here where we have to say x squared minus x into 2x squared plus 5x minus 4. All right, what do? You remember? It's only the 2nd class you've done it in. 3rd, because we introduced this in Algebra 1. Ignore the 2nd term, take leading term divided by leading term. 2x squared divided by x squared is 2. 2 times the stuff is 2x squared minus 2x. Then what? We subtracted the thing. So you change your signs. 7x, drop it, little hot. Get 7x minus 4. What happens when I try to divide now? 7x divided by x squared? Nuh-uh. Doesn't happen. So it's my remainder of 7x minus 4 over x squared minus x. That's the part you're going to decompose. This guy's just going to hang out there for a while. Okay? So you and your significant other are going to go do stuff and tell your kid brother to just go hang out by the ball pit at Burger King. Just decompose this. A over x plus b over x minus 1. Remember, GCF. So I'm only decomposing the green part. Okay? Ian doesn't matter. Shut up, Ian. Go away. He's just going to go hang out over there for a while. We'll take this times x minus 1 by x. My denominator is all the same right now. So I've got 7x minus 4 will equal ax minus a plus bx. Make your system. Match x stuff and x stuff with x stuff. A plus b is 7. Match constant stuff with constant stuff. Negative a is negative 4. Well, that was easy. So we've got a is 4, plug it back in. B is 3. I was looking for a and b. So 4 over x plus 3 over x minus 1. Don't forget your kid brother at Burger King. Don't pull into your driveway at 1 a.m. and say, "Where's Ian?" Okay, you're just going to shove that 2 off to the side for a little bit, do your thing, and then go pick up your kid brother. Okay? So divide first, then do the stuff. Baby steps. Divide first, then decompose the part that's left over. Divide first, then remainder over divisor. That is your new rational component. Decompose the rational component because you have a whole component over there. You're just going to put them off to the side. Say, you'll be good here for a few hours, right? So like 4 kids gone. Why are you quiet like first hour? Doesn't stop you any other day.
True.
Okay. Get your x plus 2, x plus 2, x and x. Multiply by the denominator, canceling it out, we get 6x plus 4 is ax plus 2a plus bx. I got this much x, this much x, this much x. System. Got that much constant, that much constant. Solve. A is 2, B is 4. Write out your decomposition. A over x plus b over x plus 2. Don't forget your kid brother at Burger King. Is that okay? Can you do it when it's bigger and uglier? Because sometimes you don't just kick your kid brother out at Burger King. Sometimes you take all three of your siblings, open the door, drift in through the parking lot, tell them tuck and roll. Sometimes it's more than just a 3 that you left at Burger King. Show me what you got.
Go ahead and change.
Why do we even have to know long division? Synthetic's so much faster. Ah, young Jedi. Much to learn you still have. Sorry, what's that? -20. Stage 1, you better be able to divide. Can you divide to get the remainder? Because it's the remainder that you're decomposing. The rest of it just gets tacked on at the end. Specifically because the derivative and integral of x squared and x and 5 can all be found separately. That's where this is headed. I can find all of those separately, so I have to be able to separate things. Good? Like, it looked big and scary at the beginning, but after you divide it, it's just the same stuff. What?
No, I didn't.
Okay. So I've got a is -1, so minus 1 over x. B is 12, so plus 12 over x minus 4. You left all 3 of your younger siblings at Burger King. You are going to end up on CNN. X squared plus x plus 5, then minus 1 over x plus 1 over x minus 4. Okay? How do we feel this far?
Good.
Like, it's a long process. It's got a lot of steps. It's got a lot of moving parts. Yet again, it's got a lot of mental math and arithmetic. A lot of little places to goof up. But it is just the process. Okay, we break this up because when you move on to calculus, you are going to use those parts, and we have to at least know how to do it to begin with. Now, turns out, when I printed out the notes, I used the unsaved PDF that does not have example 3. So, flip the page or two where there's a big box that has, where is it? There we go. It's got the big box, right? The box where we keep the knowledge. Right below that, you're going to put example 3. Okay? So with example 3, I'd like you to start by just factoring the denominator. Don't try to split it into fractions yet. Just factor the denominator. What's the first stop on any factor train?
GCF.
GCF.
We're good.
Okay. Reading the card explains the card. Okay. We'll get x squared plus 4x plus 4. It's a perfect square trinomial, so it can be written as x times a quantity x plus 2 squared. Okay? The fact that it's squared is what's important, because sometimes you get a repeated factor. Now there's a whole proof for this. I don't think you do it till Calc 2, though. There's a proof for this, why this works. But basically, because you have a repeated factor, if you only write that factor one time, your denominator is not going to be large enough. It needs more. Famous dead dude comes along, tries some stuff, and says, oh, if I just repeat this, then I'm fine. So whatever the degree is of your repeated factor, you have to repeat it that many times. If this is x to the third, I need to have x to the first, x to the second, and x to the third. If this is x minus 1 to the second, I need x minus 1 to the first and x minus 1 to the second. Now, do you see where, in that example, this is about to get huge? Because now to get common denominators, this needs 2 more x's and x minus 1 squared, which is, when I factor it, a times x cubed times x minus 1 squared. No, you cannot just call it ax to the fourth minus ax to the third and then square it. Don't distribute like a freshman. You have to take ax to the third times x squared minus 2x plus 1. Meaning I'm going to have ax to the fifth minus 2ax to the third plus ax to the fourth to the third. Which means to the fifth, to the fourth, to the third, to the second, to the first, and constant. 6 variable system. Do you see why this is done after matrices?
No.
Because you can solve big things with matrices. Knock out your x's, knock out your y's, knock out your z's. But in this case, it's knock out your a's, your b's, your c's, your d's, your e's. So, we're never going to give you anything that big. No. Now, if we had one more day of this, yeah, I would do it to you. But we're going to sim it down now. So instead, when I factor this into x minus 2 the quantity squared plus 2 the quantity squared, I'm going to turn that into a over x plus b over x plus 2. And because it repeated, because it happened twice, c over x plus 2 squared. Okay? Any repeated factors, you have to do it that many times in increasing degrees. Then, what does the first term need? For all of my denominators to look like this. Okay? Careful. What's the middle term need? All right. One more x plus 2 and an x. Why don't I want to say x plus 2 squared? Because there's a squared over there.
So then it'd be x plus 6 cubed.
Okay, you would have too much x on denominator. That would be like saying if I have 5/4 plus, I don't know, 3/8. Okay, well, they need to be, oh, and then I'll say like 7/10. Well, I guess this guy needs a 10 and an 8. And I guess this guy needs a 4 and a 10. And I guess this guy needs a 4 and an 8. Isn't that overkill? Yeah. Now, it'll work here because there's no variables, and it'll reduce down eventually. But you have to know that if you take too much on the denominator, you've actually screwed yourself over. And this guy just needs an x. All right. Hey, you, get out of here. So, multiply by that polynomial, all of my denominators go bye-bye. And I'm left with negative x squared minus 3x minus 8 is, careful, a times x squared plus 2x plus 1. Oh wait, that's an x plus 2. My own hand was in the way. X squared plus 4x plus 4. So that's ax squared plus 4ax plus 4a. Almost sounds like how they spell Canada. And then, y'all cool if I just say bx times x plus 2? Right? Multiplication's commutative. So we'll have plus bx squared plus 2bx, and then at the end just cx. You see how we're getting this big long chain of alphabet soup. You can design your multiplication in such a way that it is organized for you. Instead of hunting for my like terms, how about as I was multiplying, what if I just multiplied in such a way that I stacked stuff? Okay? Just like the box method. Just like when we distributed our big polynomials way back in chapter 1 and 2. Okay? So if I do that, it helps me build my system. I still have this much x squared makes this much x squared. A plus b is -1. I still have this much x makes this much x. 4a plus 2b plus c is -3. And thankfully, this much constant is this much constant. Doesn't always work out that way, though. This one was designed nice because they actually started with the partial fraction decomposition to make the original problem. So it's not always going to come out nice like this, and you saw we did have 3 variables there. That's why we're doing this in chapter 6, because now you know how to, you've got more tools to solve 3 variable systems. Now I don't need to go to a matrix for this because it's easy peasy, right? A is -2, plug it in, womp. B is 1, plug them in, get -8 plus 2 is -6, add 6, C is 3. Again, if you have to show more work, show more work. But I have gotten to the end of the rainbow. The point of this was to find out what A, B, and C are. I now have -2 over x plus 1 over x plus 2 plus 3 over x plus 2 squared. How do I know if I'm right? Combine them. We just reverse engineered our way to the problem. Now do the problem. Take that times x plus 2, the quantity squared. Take that times another x plus 2 and an x. Take that times an x. That numerator should come out like this, which means there's no reason for you to get this wrong on your test on Monday because you can check them. So, if you have a repeated factor, thou must. And you don't have this either, so right next to it on that back page, we'll just have you do one of these. One of these. Because that's example 4. This is example 3. Depends on your packet. What?
The stuff above example 4 is example 3. So that's like extra example 3 problems.
We'll get there eventually. Also, not everyone has the same packet of notes because I printed out 50 packets of notes, and for some reason, 46 kids still needed more notes. So some of you have old leftover packets from previous years or semesters that I happen to dig out of a pile that are different.
Who cuts a piece this big?
Who doesn't cut it before they put it in a dish? Who doesn't cut it before they put it in a dish? Yes, my plastic cutlery is to hack at this giant chunk of meat.
Just don't bring plastic cutlery. Bring real cutlery.
Or you just stab it with a fork and gnaw on it like a caveman. A little more room for B. Okay, did you factor correctly? Get your common denominators.
Since there's no x squared, was in the first equation?
And the next question is, what do I do when I'm trying to match this much x squared to nothing? Okay, equals 0, perfectly legal. And we get a plus b is 0. We'll get negative 6, a minus 3, b plus c is 1. And thankfully, 9a is 18. Don't always work out that way. A is 2. B is negative 2. Getting negative 12 plus 6 is negative 6. Add 6. C is 7. Herp. A over x. B over x minus 3. Remember, you can say minus 2 over x minus 3. Or you can say plus a negative 2 over x minus 3. I don't care. And 7 over x minus 3, the quantity squared. Now, where these start to get a little funky is what happens when I have a repeated factor and my numerator is greater.
Example 4.
No, that's even more. I need a t-shirt. What? You would have to divide, and then you would have to split out with a repeated factor like this. Now, the more factors there are on the denominator, the more they're repeated means the more partials you're going to have. The more partials you have, the bigger the system. The bigger the system, the more likely it is you need to go to matrix town to finish it. Now, we didn't really get to our 4 variable systems, but we showed you how to use a calculator, right? Notice every single time that we've been doing these, we've had a linear factor on a denominator, even if the factor is repeated. It was always a linear factor, so there was a constant above it. We spent so much time in polynomials because all polynomials can be broken down into linear and irreducible quadratic factors. Irreducible quadratic factors are when I can't factor it without using I. So, here we go. Don't do that. Bad Frank. First of all, what is the total degree of the denominator? Because I got to make sure if I need to divide. It is x to the 5th because you've got 2 x squareds and then another x. Okay, good. I don't have to divide. So when I'm breaking this up, we know we're going to have x. All right. Plus something over x squared plus 4, and then it's repeated, something over x squared plus 4, the quantity squared. Because, how do you factor x squared plus 4? Remember sum of squares instead of difference of squares? Plus or minus 2i, right? Because if it's x squared minus 2, versus x squared plus 2, right? So sum of squares just means you do the same thing, but you got an I in there. Well, I now have sum of squares. I don't want to start factoring and getting common denominators with i's all over the place. So what we'll do instead, a linear denominator had a constant numerator. So what will a quadratic denominator have? Linear numerator. So bx plus c. And, oh, no, I got the wrong color here. bx plus c and dx plus e. And this is where we go to 5 variable systems. Okay. Now you're still going to do all the same stuff though. What's this guy need? What's this guy need? And this guy just needs x. Do the same stuff you're doing, it's just uglier. Womp. Now this is one of those cases where it might not be a bad idea to write a little more and do a little less in your head. We have x to the fourth minus 2x to the third plus 8x squared minus 5x plus 16, I swear that's an x, is a times the quantity x to the fourth plus 8x squared plus 16 plus bx squared plus cx times x squared plus 4, so I just distributed the x into one of them, plus dx squared plus ex, distributing one of them. So I'm taking this in stages. Keep distributing. You see why you want a system when you're distributing? You probably want to line up your like terms because this is going to be just one big, long alphabet soup. Oh. So we're going to have ax to the fourth plus 8ax squared plus 16a. Yes, it is a child. I'm going to distribute here too. I'll have b x to the fourth 4bx squared cx times x squared is cx to the third. Cx times 4 is 4cx. And then this last guy over here, dx squared plus ex. I put that one in the wrong column. There we go. Now, yes, it's big. Yes, I can write that as a system with a matrix because it's how many x's? And then you do a, b, c, d, e. How many x to the fourths and so on. So this would be 1a x to the fourth, 1b x to the fourth, 0c, 0d, 0e is 1. Then I'd do x to the third. Well, that one's easy. 0a, 0b, 1c, 0d, 0e is negative 2. I'd have 8 a's, 4 b's, no c's, 1 d, 0 e's is 8. Do you see how you can make the matrix out of it? If you can do that, you can also dump it in your calculator and ref. Okay? Now, you don't have to do that. I'm just saying if it really got nasty, you can. You can solve a multivariable matrix. You can dump it in your calculator and reduce row echelon form. I'm telling you, you don't have to because this isn't actually that bad. Because I have a plus b is 1. I've got c is negative 2. I've got 8a plus 4b plus d is 8. I've got 4c plus e is negative 5. And the tank of the team 16A happens to equal 16. Do you see how that makes the system fairly easy? Because now A is 1. Plug it in. B is 0. They just straight up tell me C is -2. Well, if A is 1, plug it in here too. A is 1. No. 4 times 1 is 4. Subtract 4. Why was I pointing at C?
A little confused there.
I mean, we just did C. If C is -2, there we go.
Yeah.
-A, plug it in, E is 3. Maybe it's just the sound of the child's voice made me dumber. Happens to parents. Okay, plug in A, plug in, what, I got B is 0, that's nice. So 8 plus 0 plus D equals 8. D equals 0. Can you now write all of that with A, B, C, D, and E? Cool. Example 4 will not be in your homework or on your test because first hour didn't even make it that far. Okay, I wanted to show you because we had the time and y'all doing good. Reminders. Monday test. It is a white day. It is important that you get your notebooks to me, especially because there's only about 5 or 6 of you who actually turn them back in for me to go through them. I know that we had stuff happening. It's been happening for the last 2 months. I'm sick of it. But get your notebooks in on Monday. Is there anyone who knows they're going to be gone Monday or Tuesday? Because Monday is test. Tuesday, you start chapter 10, and I'm not here. So you need your notes before Tuesday, because you're doing it on a video. What's up?
I still coming.
Spartan time today is a good day to get tests done if you're missing some.